can't believe that. We are already at the last session of the day, guys. I hope you've enjoyed everything so far. It's been such a great experience. Next, please welcome Saumya Srivastava, Senior Manager of Data Science at Sam's Club, Walmart. At Sam's Club, she leads the data science efforts for marketing and membership verticals, focusing on personalization, designing, optimizing, and measuring marketing campaigns. Today, she's here to share ways how machine learning is revolutionizing marketing analytics in serving the customers in the best way while also saving marketing dollars in the process. Over to you, Saumya.
Hi, so good afternoon, everyone. So my name is Saumya, and I work as a senior manager at Sam's Club Decision Sciences team. So here I lead the data science efforts for marketing and membership verticals, focusing on personalization, designing, optimizing, and measuring marketing campaigns. So today I'm going to talk about this topic, creating personalized and optimized marketing campaigns using machine learning. So my talk is not going to be very technical or very mathematical, but it's going to be more towards sending you the right kind of information, because all these technical and mathematical information you can find online. So my focus is going to be more about how we can use machine learning to help the business. So I work for Sam's Club. So here, if Sam's Club is an American chain of membership-only retail warehouse clubs owned and operated by Walmart. So it was founded in 1983 by Mr. Sam Walton, who is also a founder of Walmart, and the company is actually named after him. We have about 600 warehouse-styled stores spread across the country, where we sell hundreds of thousands of products ranging from grocery to everyday items to jewelry to pharmacy and many more. So also we have our own premium quality private labeled products, which we go by the label name as Members Mark. The third thing is the business model. So it follows a two-tiered membership approach. So $100 for the Plus membership and $45 for the Club membership. Our corporate team actually works really hard to make sure our members save more than they pay for their membership through our exclusive savings and perks on our different categories in terms of merchandise, our products, or fuel, or prescriptions, and more. And the good news about our team is last year our Decision Sciences team, we won the New Star ANA Marketing Genius Award and Retail Innovations Award for the amazing work we have been doing here. So the agenda for our talk today is going to be mainly towards, I'll start with giving you a brief look into how our CRM marketing journey looks like, followed by some of the machine learning models we have developed, which are helping us in supporting our membership and marketing verticals, like the lookalike model, the uplift model, and the personalization engine. So the CRM marketing journey. So before we jump into any marketing campaign that comes our way, we need to first address the basic questions, the 5 W's. Who are we trying to market? Do we have a target set in place? The what, as in what products or services we are trying to offer or promote. The where, as in which channel we are trying to market with, or is it a direct mail, an email, or a Facebook ad? The when, is it like a holiday specific campaign, or is it a back to school campaign? The time of the event matters as well. And the last one, the why. What's the purpose of this campaign? Is it an engagement or a retention or an acquisition campaign? The metrics here, the KPIs, it needs to be defined beforehand. So once we answer these questions, the next steps become really clear. We start with choosing our target audiences. This is a very important step, and we would get to that later when I talk about targeting in detail. The next step actually is setting up an experiment with the test control groupings and creating hypotheses. So we want these to measure how the campaign performed. With no control group, you'd just send offers to the target group, and any response you'll see will sound very amazing because it will only be false information that the campaign is working when in fact there is hardly any incrementality because there is no control group and we are just losing money at the end. So once we're ready with the groups for test and control, we have done the bifurcation and everything. We start to collaborate with our different teams, cross-functional teams, to execute the campaign so that the test group receives the marketing offers and the control groups either does not get any offer or they get some kind of pseudo offers. So once we are done with the execution, we just wait it out until the campaign ends and it is time for our statistics-based measurement. Next comes the machine learning part. This is my favorite part because I work mostly on this section. We are done with the campaign. We have learned something, but now we want to optimize this for the next campaign or the next time, whenever a similar kind of campaign is going to go out. So that's where models like the lookalike or the uplift models really help. All these models, they learn from the campaign and they try to optimize it for the next time. So targeting is one of the cores of marketing actually. So why is targeting important? So it would be if companies had all the time and all the money in the world, but it's not exactly true. We have limited marketing budget and limited resources, and we want to make the best use out of it in finding the ideal customer. That's the whole fight about. So finding the right customers is really hard. As a first step, we can start with understanding the customers and segmenting them based on the very typical groups. One of the popular ones we create mostly is the customer behavioral data is RFM. So RFM is recency, frequency, and monetary value. So a combined metric is created out of those three metrics using customer spend, how frequently they are visiting the store, and how long they take to come back to the store. So the other ones we actually use on top of these RFM metrics in combination or standalone actually are the demographics segmentation or geographical segmentation or psychographical segmentation. All these segmentations are awesome, but they still need machine learning because machine learning, it uses all these features of the customers and it tries to learn the hidden features which are not really visible to the naked eye and come up with the better targeting. So next, one of the first models we actually use is called lookalike propensity model. So as the name suggests, this model tries to find lookalikes of already engaged customers. So we have our seed segment who are already enrolled with the campaign or have responded positively to the campaign in the past. So the aim here is to try to learn from them and try to find similar looking customers from the group who are yet to engage in terms of data features coming from their transactional history, their demographics, psychographics, or any other data sources you have. So, for example, we want to do a campaign to promote apparels in Sam's Club. We know, let's say we have a customer named Ali who buys apparel from Sam's Club. So now that people like her, customers like her, are going to be a seed segment. Now we want to find out the traits of Ali and find customers with similar traits in the rest of the group who haven't bought apparel yet. So the labels, the target variables here are the ones who have responded in the past are going to be positives like Ali, and the ones who hasn't or have never responded to the any campaign, any similar campaign in the past are going to be negatives. The model is our very own, same old typical classification model trained on prep data from the first step we just saw, and they are validated or tested on the test data, which was separated out initially as part of the machine learning process. So we look at metrics like ROC curve, precision recall, F1 scores to come up with the best model. So once we have all the model ready, the target design starts. We have the customers and their predicted probability ready. We sort them out in descending order based on their predicted probabilities and decile them into 10 equal parts in the order that you have the top decile with the highest probabilities and the bottom deciles with the lowest probabilities. So based on the marketing budget you have for the campaign, you can actually choose the right customers starting from the top decile. So let's say you have a marketing budget of just two deciles, you can just choose the top two deciles, and then once you have done that, you can split them through random processing, randomized control trials into test and control groups, and they should be the sample size should be large enough so that the results they are going to give to us are statistically significant. So that was our lookalike model, but a couple of things to keep in mind when we are building these propensity models. First of all, the data is very heavily imbalanced. So why is that? Well, we have only a small chunk of customers who are enrolled or who responded to the campaign as positive. So there are so many others who haven't responded or are yet to be enrolled. So we are trying to change that actually through this model. So we often need to take care of that by using different methods like oversampling or undersampling or synthetically creating data and many more methods which are out there. And more often than not, this imbalance causes another problem, which is classification. This is incorrectly predicting the positive or the negative classes. What it means is the model is incorrectly thinking that a customer is going to respond to our campaign when actually he is not, or maybe the model is thinking that a customer is not going to respond to the campaign when he actually is going to. So this classification is generally costly, and that's the opposite of what we're trying to achieve here. We want to optimize our campaigns. So looking at the metrics here, accuracy, it's basic metric. It tells you how the model fares overall in terms of total predictions, negative or positives. So it doesn't really care of the misclassification. So that's where our other two metrics come really handy, the precision and the recall. So the precision tells you how correct are the positive predictions. Low precision means the model is assigning positive to customers should have been negative. And if you go ahead with this model, you would send offers to these customers who are probably not going to respond anyway, thus losing the marketing dollars in the process. Similarly, for recall, it tells you how correctly is the model able to cast the actual positives. So lower recall means the model isn't doing a very good job of catching the signal and finding the probable positives in the data. So if you miss out on these potential conversion, who would have responded when marketed with these offers, you're just losing out on your revenue, on the money you could have earned. So what we learned here is accuracy isn't enough to determine if the model is good or not. Ultimately and ideally, we want a model with a high precision and recall. If not, find a model by creating a misclassification cost matrix and try to calculate in some way how we can minimize the cost. So next is the uplift modeling. So before we discuss what uplift modeling is, we want to know why we are trying to implement this model. So we discussed the propensity models and they sounded amazing, but they have a few drawbacks. It only tells you the likelihood if a customer is going to purchase or respond. It doesn't really tell you whether this likelihood is coming because of the marketing or that they just might be interested in the purchase of their own. We cannot really tell the difference. Secondly, the propensity model doesn't directly learn from the past experiments. So we need a way where a model tells us how much a customer is persuaded to convert because we marketed to them. That's where uplift models come into play. It makes it simpler. Let's go with Ali, for example, here. We built a propensity model to find out how likely she is to buy an apparel at Sam's. The model tells me Ali is 80% likely to buy apparel. So naturally, we are going to market to her because that's a pretty good probability. Uplift model, on the other hand, tells me that if we market to Ali, we can increase her likelihood to buy apparel by 10%. And that tells me a the marketing strength, how much it is able to persuade customers like Ali to buy from us. So that's the beauty of uplift modeling. So what is uplift model? Uplift modeling is a prescriptive technique which predicts how each customer is likely to respond to a marketing action. Based on these actions, marketing teams can determine which customer should be targeted in order to maximize the ROI of our campaign. So let's look at this matrix here. On the x-axis, uh, on the y-axis, we have the marketing action. On the x-axis, we have the what happens if there is no marketing actions. So these four quadrants are pretty aptly named. Starting with the sure thing, these are often your loyal and highly engaged customers. They will probably convert or shop with us no matter if you send them the marketing or not. So that's what this says. They will convert with the marketing action, and they will convert without the marketing action. Next is our lost causes. Lost causes, on the other hand, actually are the customers who are not going to convert irrespective of marketing. So it doesn't. They don't really care if there is going to be a marketing action on them or there is not going to be a marketing action on them because they are not going to convert. Uh, the third one is actually the sleeping dogs or the do not disturb quadrant. These are the ones who you do not want to be disturbing with any kind of marketing. They are probably one of those customers who are already on auto renew and they have forgotten that they are enrolled with us. So if you try to market them a number of times, the marketing could actually remind them about the enrollment and they might cancel and uh, there it is that we will start to lose our money from that part. Lastly, but most important quadrant is the persuadables, and that's where uplift model is really helpful. So these are the ones who will convert only if you market them. So this is our target group, and we do not want to miss out on them in terms of marketing, as here you will see the most incrementality coming from. So as you can see here, with marketing action, they will convert, and without marketing action, they will not convert. So in short, we want to exclude our sure things because they are going to convert anyway. We do not want to go after lost causes because they are not going to convert at all, and we are not definitely not going to go after sleeping dogs. So the only quadrant we want to go after is the persuadable segments because they will only convert once we do some kind of marketing action on them. So this is highly beneficial. In doing so, we are saving marketing dollars by only going after our target group and not pursuing the rest of the three quadrants. So here in Sanskrit, actually, we have executed a number of campaigns using uplift models and have seen significant lift in ROAS and also have seen a huge reduction in the CACs of each of those programs. So how is uplift modeling done actually? So before that, a couple of things to keep in mind again. For developing uplift models, we need data from the last campaign with the test and the control groupings. And the campaign should have seen enough incrementality against control groups to prove that the marketing is actually working on it. So if you are seeing an incrementality of, let's say, 0.0001, then the uplift model is not going to help. It has to be more significant than that. So let's start here. We have the test group here, and we have the control group here. What we do next is we train two separate models. So one is trained using the data of customers from the test group only. While it can use all those features we usually use with our propensity model. It is going to be a propensity model which is trained on the test group. So you can use your purchase data, your geographical data, or any different other data sources you have. And parallelly, we train another model in the same way, but this time we are using our control group only. We are not using our test group. So ultimately, we end up with these two models, and in the next step, we score each of these data sets with the other model. So what we are doing here is we are scoring test data set with the control model and we are scoring the control data set with the test model. So So that in this way, we are actually ending up with two sets of scores for each of these data sets. So what exactly is happening here? So scoring on control model is telling us the propensity to buy when there is no marketing, versus scoring on test model is actually telling us the propensity to buy when there is some kind of marketing. So when we calculate the difference between the two scores from the test model to the control model, any lift we see is the incrementality in the likelihood of purchase, and it can all be attributed to marketing. So this is how the uplift score formula looks like. So a positive score means they were more persuadables because we have seen an incrementality in the uplift score. No incrementality are either sure things or the lost causes from our quadrants, and negative scores are our sleeping dogs. So we definitely do not want to go after our sleeping dogs. We have actually different kinds of uplift modeling. Some of them use just one model. Some of them, like this one, uses a couple of models. Uh, I find this one most intuitive because it actually tells me the score and how it is coming from. So I use this one. So next is the personalization engine. So that was all about uplift modeling and how it saves our marketing dollars. So now let's talk a little about how to improve our customer engagement. Recommendations engines are really very popular now. So every popular online or e-commerce business is developing it and using it, whether it's Amazon or the streaming services like Netflix. But it's not so popular among the offline brick and mortar businesses like ours, Sam's Club or Walmart. Reason being, it is very challenging in a business setting of brick and mortar for a couple or for a few reasons actually. Firstly, there are limited ways in which you can capture customer journey in terms of transaction history. You only have their purchase data. While in case of e-com, you have no dearth of data. You can see the whole journey the customer takes, right from uh, trying to add something to their cart, to the page visits, the visits, and the abandonments, the search queries, and everything. Secondly, there is no explicit ratings or feedback in the form of likes or dislikes available uh, on these settings. Like for example, in the e-com business, you go to the website, you like a product, and you probably like or dislike it or put in some kind of review. It doesn't really happen in the offline setting. So all these recommendation engines, these algorithms, they do those explicit feedback, which is not the case here. We can only rely on our implicit feedback, which is in the form of customer side transactions. The problem with these is they do not really tell you if a purchase is positive or negative for the customer. So if an item is bought, and does this mean that the customer is happy with the product? Or if an item is not bought, does this mean the customer did not like that product? It could be that he is not even aware of that product. So that's how it becomes really challenging. So thankfully, we have a workaround with the implicit feedbacks, which I'll show you in the later slides. And how we are doing it is we are creating our own set of custom rules to interpret our implicit feedback. So there are different algorithms available with recommendation engines depending on what the business problems you are trying to solve. So user-based collaborative filtering tries to find the relation between the user based on the items that they are purchasing. So it doesn't really need any information about the users or the items individually. So it doesn't really care where the users are residing or what their demographics like, or it doesn't really care about the items and its features like what color is it, what category it belongs to. No, it doesn't really care about all that. So it just needs to know the interaction between the users and the items in terms of the purchases. So it looks at customers' basket and finds similar customers based on the items that they are purchasing. So it assumes that if two customers are purchasing similar items in the past, they are very likely to have a similar taste and will continue to buy similar items in the future. So, so let's take an example here. So this is Ali. She's buying beauty products, let's say from Sam's Club. Now she's also buying dog chow, dog food, she's buying snacks, and she's also buying some pharmacy drugs, right? And now here on the other hand, we have Sally. She is also buying this same beauty product. She's also buying dog food, the snacks, and the pharmacy drugs. So as you can see, Ali and Sally, they both have very similar baskets. They both are purchasing very similar items in the past. So we can say that they are very similar to each other. Sally, on the other hand, is what she's doing different is she's also buying this sports drink or Gatorade, for example, here. So what the model does is it reads that and it recommends Gatorade to Ali because it assumes again that they have agreed in the past, so they are very likely to agree in the future. So Ali would probably buy Gatorade as well. Okay, so to get into more detail about its implementation, as I stated earlier, customers' purchase data can be used as a replacement for explicit feedback. So you can use either sales or count of the items purchased per visit as a good source of implicit feedback. So what we can do is we can set up a threshold of n number of items based on the business understanding to differentiate between the positive and the negative feedback. So, for example, let's say you think that if a customer is buying a product just once, we cannot really say whether he is happy or not happy with it. But if he is buying that product again and again, it's a definite that he is actually liking this product, and we can consider this as a positive feedback. So for the algorithm and finding similarity, there are different methods out there, like using cosine similarity method or Pearson's correlation method, which can be used to calculate the similarity among customers. However, matrix factorization, which uses the alternating least squares, is very popular among them. Essentially, we take a really large matrix of user on one side and item on the other side, and we label the interactions. So what ALS does is it tries to figure out the latent or the hidden features that relate them to each other in a much smaller matrix of user features and item features. Uh, so that's exactly what ALS is trying to do through matrix factorization. So ALS is really especially beneficial in retail cases where there is huge amount of data. There is no dearth of data. So it serves matrix factorization by solving the scalability problem and also the sparseness of user item matrix by creating smaller matrices of user features and item features. For evaluation, we can use the same metrics we use for classification problems. Essentially, we are needing to see if the order of recommendations given for each user matches the items that they end up purchasing. So ROC curves are really helpful here. So what it is the area under the curve. What it means is the greater the area under the curve, it means that we are recommending items that end up being purchased near the top of the list of the recommended items. So as a benchmark, actually, in order to compare whether our AUC is actually good or not, what we can do is we can calculate the mean AUC for the simply recommended products from the popular items. It's actually very hard to beat because popular items are very much marketed and they are very much purchased. So if your model or your algorithm is able to beat the most popular items recommendations, you could consider it as a very good model or a algorithm. So adoption of personalization engines have proven to be a boon to not just the e-commerce apps, but also in the marketing world, especially in the emails and the digital ads. So the campaigns are given a very personal touch to it because now we have reduced the clutter and we have filtered out the irrelevant content because earlier what you would probably do is you would just randomly put in items into your emails without really knowing whether it's actually reaching out to your customers or not, whether they are interested in those items or not. But using these personalization engines, uh, since we have personalized those ads or those emails, it actually helps the customer getting more engaged. So what it does is it increases your CTR, your click-through rate for the emails. Increment in CTR will in turn, increase the conversion in the customers. They will be more happy with the campaigns, and they will more likely they're going to buy something which they are interested in. So happier customer means incremental retention because they love your products, they love the engagement, so they are going to be retained with us. So this in turn actually increases the CLV, the customer lifetime value, because they are more profitable now, and this again helps in increasing the ROI because now you're earning a lot more money and you're more profitable with the whole thing. Oh, that's it from me. I'll open the table for question and answers.
Thank you for joining today's DSS mini virtual salon, and I hope you had a great time and learned a ton. Don't forget, you could come back here and experience all of the sessions on demand for the next 2 weeks, and you can also continue the conversation over on our Slack channel. This is where you can engage with other DSS community and continue to meet like-minded individuals like yourselves and our partners and other speakers, and we hope to see most of you there. Also, please take 3 minutes to take our survey. We would love to hear from you, and we dropped a link in the chat just now, and you also will receive an email about this very shortly. But we do these events for you guys, and we want to make them the best that they could be for you, for our community, and please give us the feedback of what you want to see in the next one. And again, big thanks to our sponsor, Snowplow, and their support ensures that we can continue to bring great events and content to you guys, and also continue to contribute to the data science industry. And on a final note, we hope to see you at the next DSS virtual event focused on fintech on December 1st, and registration is now open. Also, we'll drop a link for you. Thanks, guys. Have a great rest of the week.